Right, here's another word problem. And I'm not going to read this to you because you've got it on the screen in front of you. You can read yourself. So pause it, read it, figure out what's going on, and then we'll quote unquote discuss it a little bit. So what we have is a function. The number that goes into the function, t, that's the x coordinate, that tells us how many seconds, or that is how many seconds since the ball was thrown. And then the number that we get out of the function, the value of the function, the y coordinate, is the height of the ball in feet. Now, you all know when you throw a ball up in the air, it goes up and then it comes back down. And that's like an upside down parabola. It's got that nice symmetric U shape. And that's what we're looking at here. The difference between this and the ones we did previously, the multi-generation households and the funding for Afghanistan or whatever, is that this one isn't asking us about a particular moment in time or a particular height. It's asking us to find when the ball reaches its maximum height and how high that is. So if we throw the ball up in the air from an initial height of 6 feet with a particular initial velocity, it's going to go up, then come back down. We want to find the top of that motion. And here's how we're going to do that. We're going to use the calculator. Go to the y equals screen and put in the function. We get negative 16x squared plus 20x plus 6. We go to our graph screen, and it's not a real nice graph. It's okay. We can tell it's an upside down parabola, but let's look at this screen here. Let's adjust this a little bit. It looks like it lands after only about 1.5 seconds. So I'm going to change my window to go from 0 when it was launched to 2 seconds. And then the height is going to go from 0 to, well, I don't really know. Looks like it goes up off that screen, but I guess it would be around there. I'm going to say maybe set the height of the window, my Ymax, to 12. And go back to graph there. And nope, not quite high enough. And I knew that was going to be high enough. I wanted to illustrate you don't have to get it right on your first time. You can play around with a window as much as you want until you get a picture you're happy with. It's not like it's going to be hanging on the fridge. You're just going to use it to answer a question. So it starts at 6, goes up to somewhere, and then drops back down to the ground. And that's the entire flight of this ball. Now, we want to know when it hits its highest point. There's a few keystrokes here. You're going to want to write these down. Second trace. We're looking for a maximum. We're looking for a highest point. So you can either hit 4 on the keyboard or you can arrow down and hit enter. Now, in order for the calculator to find the maximum for us, we have to tell it roughly where the maximum is. We have to say, look between this place and this place. And we're talking x coordinates. So I want to say, look between here and here. That's where the highest point is. So I'm going to arrow over to the left. Notice it says left bound down there. That's what it wants. Move the cursor to the left of the vertex. You don't have to go past it very much, just a little bit. Hit enter. Then it wants to know the right bound. So you move it to the right bound. Hit enter again. And then enter a third time. I apologize, my screen is a little big there. Down to size so you can see the keys. And it's telling us the maximum occurs at 0.625, 12.25. Now remember what the function stands for. The input to the function is the time. The output of the function, the y, is the height. So after 0.625 seconds, the height of the ball was 12.25 feet, and then it started coming back down. Right, so you just need to keep straight which one is seconds and which one's feet. And if you're paying any attention at all, that's pretty easy to do. Just think to yourself, throw a ball up in the air and it's going up for 12 seconds and it only gets to 0.625 feet in the air. That's ridiculous. So you should know that that is not correct. All right, let's do one more of these. Got a model rocket one here. A model rocket is launched with an initial velocity of 120 from a height of 80 feet. And notice, just like last time, those two numbers are in our equation. The constant is the height it was launched from, and the initial velocity is the other number there in the middle with the t. And the negative 16t squared, that's because we're on Earth, and that's gravity. So that's going to be a constant throughout these problems, as long as we're working with feet and seconds. So we've got our equation, and again, determine the time at which the rocket reaches its maximum height, and what is the maximum height. So go ahead and plug that stuff in there. It was negative 16x squared plus 120x plus 80. Right? Let me get back out here a little bit. There we go. Okay, so if we go to graph now, I'm not going to see much useful because my numbers are much bigger than in the previous one. So I'm going to have to set my window. Well, let me go zoom 6 first back to the home screen, and then we can maybe get some information. It looks like the ball comes down after about 8 seconds. So I'm going to set my window to show from 0 to 8. You know what, I'm going to go to 10, a little bit past it. So X min always 0. X max, this time I want to see that flight for 10 seconds. Y min's always 0. And Y max, here I really don't have a good sense for that. So I'm going to go to my table, and I'm going to see my numbers are, it looks like it gets up just a little bit above 300. So I want to be able to see that. So I'm going to set my Y max at, I'm going to go to 350. So now you should see the ball go up, hit the maximum, turn around, come back down. Right? And our job is to find that maximum there. And the way we do that again is second trace to get our calculate menu. This time we're looking for a maximum. We need to move the cursor to the left of the maximum. Enter. Move the cursor to the right of the maximum. Enter. And enter a third time, right? It's looking between those two little arrows to find the high point. And the reason we need to do this is your graph might have multiple high points that you want to find. So we kind of need to limit it to which one it's going to look for. Hit enter again, and we get our vertex, which is 3.75, 305. And you got to remember the X is the time. So 3.75 seconds, almost 4 seconds, it took to get up to a maximum height of 305 feet. And that's all there is to doing these throw a ball in the air problems.